For customers looking for high availability, similar to Oracle RAC but with less complexity, lower cost, and flexibility to run in any cloud, Oracle Single Instance with InfoScale is an optimal solution. In this video, I will be demonstrating how to convert Oracle RAC to Oracle Single Instance with InfoScale. At a high level, this demo involves Oracle RAC configuration of 2 nodes with automatic storage management as a primary database and Oracle Single Instance deployed on a 2-node InfoScale Enterprise configuration as a standby database. Oracle Data Guard with RMAN is used to first duplicate the data from the Oracle RAC primary database to the standby Oracle Single Instance with InfoScale, and then a switchover is conducted to make the standby the primary database. Now let's get started. Here are 4 window tabs: Oracle RAC Node 1, Oracle RAC Node 2, Oracle with InfoScale Node 1, and Oracle with InfoScale Node 2. From Oracle RAC Node 1, let's check the configuration. Using the SVRCTL utility, there are 2 instances running on 2 different servers. Also, the name of the database is ASM RAC, and data is on disk groups ASM test DG. The location of SP file and password file are also in this disk group. From Oracle Single Instance with InfoScale Node 1 tab, there are 2 nodes running in a cluster. A volume is created from a disk group and mounted. The Oracle SID is new SIDB. Note that the volume is also mounted on the other InfoScale node. Let's begin the steps to the conversion. At Oracle RAC Node 1 tab, the first step is to alter the database to enforce logging. Step 2 is to copy the password file from the primary to the standby. Step 3 is to configure the standby redo logs on the primary. The number of standby redo logs is calculated by the maximum number of log files plus 1 times maximum number of threads. In this example, there is a maximum of 4 log files and 2 threads. Thus, the total number of standby redo logs is 10. Use the alter database add standby log file thread to create the 10 standby redo logs as shown. Looking at the redo log files, we see 8 redo logs and 10 standby redo logs. Step 4 is to check to make sure that the automatic archival log is enabled. Step 5 is setting the database initialization parameters. Set DB unique name to unique name a database, which is ASM RAC. Set log archive config to primary and secondary service. Set log archive destination 1 to local archive logger primary. Set log archive destination 2 to standby archive. Then set state of log archive destination state 1 and 2 to enable. Set the fetch archive log client to primary service and the fetch archive log server to be the standby service. Set the DB file name convert to convert the data file name on the primary database to data file on the standby database. Set log file name convert to convert the log file name on the primary database to the file name of the log file on the standby database. Set the standby file management to auto so that data files created in primary will automatically be created in the standby. Then create a P file from the SP file. This P file will be used as a reference to create the P file on the standby node. Step 6 involves modifying the listener.ora and tnsnames.ora files to include the entries for Oracle RAC database and standby database on both RAC nodes. Now let's verify that we can ping both primary and standby services using TNS ping from both nodes. Now we will prepare the standby node. In Step 7, make the required audit dump directory. Step 8, configure the listener.ora and tnsnames.ora files to include the entries for primary and standby database similar to what was specified in the primary. Verify that we can ping both the primary and standby services using TNS ping from the Oracle Single Instance with InfoScale nodes. In Step 9, copy over the P file from primary to standby database. Modify this file to reflect the initialization parameters for the standby database. Running a diff on the P file of the primary and the modified P file of the standby, we can identify the changes that were made. For instance, there are parameters for one instance in standby, and the cluster database parameter is false. You will also notice some of the parameters of the standby P file is opposite the P file of the primary. For example, in the P file of the standby, the fetch archive log client parameter is the standby service, and the fetch archive log server is the primary service, whereas in the P file of the primary, they are set to be the opposite. Likewise, the log archive destination 1 and 2 reflect the converse. Once the P file of the standby database has been modified, start up the standby database in no mount state. In step 10, we will verify the TNS connectivity on both RAC nodes and standby DB. Once we validated that the TNS connectivity in both primary and standby, we are now ready to use RMAN to duplicate the database from primary to standby. In step 11, run RMAN and connect to the target and standby database. Then run a duplicate to copy the primary database to the standby. Once the duplication has been completed, from the standby InfoScale node window, run a verify of the standby redo log. In step 12, create an SP file for the standby database and then shut down the database and restart it. Step 13, check the database role status for standby database and then start the manage recovery process. In step 14, verify that the number of threads and max sequence should be the same on both primary and standby databases. We are now ready to run a switchover. On the primary database, check the switchover status on both RAC nodes is set to standby. In step 15, let's now verify and switch over from the primary to standby database. Once the switchover is done, the Oracle RAC database is no longer running and is shut down. The standby now becomes the new primary database. The final step involves placing Oracle's single instance under control of InfoScale Enterprise for high availability. This can be done via the command line, the Veritas InfoScale Web User Interface (VIOM), or modifying the main.cf configuration file. In this example, we will modify the main.cf file and restart the cluster. First, let's shut down InfoScale High Availability Services. Then edit the main.cf file and add the services related to Oracle. Add the cluster file system mount service group, which will mount the volumes for Oracle on both nodes to allow for fast failover of Oracle services. Add the service group for the cluster volume disk group being used for Oracle data. Add the interdependencies between the service groups added. Then add the Oracle service group that defines the resources required to online Oracle services such as Oracle SID, Home, Listener, and virtual IP addresses. Verify the syntax correctness of main.cf file using HACF utility. Then copy the main.cf file to the other node in the cluster. Restart the InfoScale services and validate that Oracle services are up and running. This concludes the demo of how to convert Oracle RAC to Oracle Single Instance with InfoScale using Oracle Data Guard. Thank you for watching.